Hello folks, I'm going to try to hand hold this so you can hopefully see it. You can work the camera a little easier. I want to take a look here and see that we're going to talk about parallel only circuits. Now this is a term I use, I'm not sure anybody else uses it, but it's to connote that we're talking about a circuit where there is only single parallel circuits together. So in other words, all the one end of the components hooked to the positive end of the source, and the bottom end of the circuit is hooked to the negative end of the source. Schematically it looks like this. I could add as many components as I want as long as the top's positive and the bottom's negative, or across the source would be the more accurate way to say that. But there are four things we think about when we're talking about a parallel only circuit. One is voltage is constant, or voltage is the same. In other words, in this case, when I'm looking at this scenario, is source voltage is going to be across R1 and R2 simultaneously. So if source voltage is 1 volt, then the voltage on R1 is 1, and the voltage on R2 is 1, and the total voltage is 1. So there is only 1 voltage in that circuit. The second thing is the total current, or amps, is equal to the sum of the branch current. So each one of these legs of our circuit, that 220 ohm resistor and the 330 ohm resistor, has a branch current, and those two branch currents in this case would add up to total current. My total resistance is smaller than the smallest resistor. That means that my total resistance is going to be smaller than 220, because 220 is my smallest resistor. Seems counterintuitive, but if I'm driving down a road and they open up more lanes in a road, it's easier to travel down the road than if they were to take lanes away. And the last thing is total power is the total of the power from each resistor, in this case, or from each component. So let's take a look at what I'm talking about. There's a schematic drawing of what we look at. And we said total resistance is smaller than the smallest resistor. So let's take a look at my circuit here. And I've got two resistors in parallel, and that is a 330 ohm and a 220 ohm, sort of hard to see there. Those two in parallel should equal around 132, and this is what we see with my meter when I'm looking at my circuit here. This is how you would calculate that. There's a couple of different ways we can calculate that. This first formula here is called the product over the sum, where I multiply the two components and then I divide it by the sum of those two components. It's the product over the sum method, so 220 ohms times 330 ohms divided by those two added together. So that's 72,600 divided by 550. My answer comes out to be 132 ohms. Another way to calculate this, and I call this the universal formula. This formula here is when you have two components or you have two resistances that you're adding up. That's product over sum. This is called the reciprocal formula, or the universal formula, sometime I call it, because this works with most scenarios. And basically how you would set that up would be the reciprocal of 1 over 220 plus 1 over 330. When I go through the calculation, it looks like this. And I get the same answer somewhere on there. And I should get 132 ohms on that also. So just want to take a quick look at parallel, and this is the beginning of our understanding of parallel. We'll look at some other circuits when we add resistors, what happens to current, resistance, voltage, and power. Look forward to talking to you again next time.